Okay, so just before we go for a break, some of you might have noticed with gradient, sometimes the number comes out as positive, sometimes the number comes out as negative, okay? So what do you think that means? If the number comes out as positive, if your gradient comes out as positive, what does that mean?
Well, if it's positive, the line goes up that way, and if it's negative, it goes down.
Exactly, okay? So remember the definition of gradient, every time I step across by 1 in that direction, it's how many I move up or down by. So fairly intuitively, if the number is positive, it just means I go across by 1 and up by 1, okay? Whereas if the number comes out as negative, it means if I go across by 1, I go down by however my gradient is, okay? So positive just means uphill, negative just means downhill. All good? Okay, so far, we have been looking at points, and we've been looking at kind of geometry to do with points, hence why it's called coordinate geometry, okay? What we can do now is think about, well, what happens if we look at sets of points, okay? So if we look at a set of points, okay, so we're going to look at a set of points that all have some common relationship between them, okay? And actually, if we look at what happens with a set of points, what we can do is join them together to make a line. So effectively, I want you to think, a line, all that is it's just a set of points that have some common relationship between them. Is that okay? So, obviously, a point has two coordinates. You have an x coordinate and you have a y coordinate. So what I could do then is I could create a table of numbers according to, okay, you give me an x coordinate and I can tell you what the corresponding y coordinate would be. So let's draw out a table of numbers from, say, -4 to 4. Okay, so table of numbers from -4 to 4. Okay, and let's suppose, I'll keep it simple, let's suppose I am just going to draw the line y equals 2x. Okay, so what this tells me then, the rule that I'm looking at for my set of points, is that my y coordinate is 2 times my x coordinate. Okay, my y coordinate is 2 times my x coordinate, right? So if my x coordinate is -4, what is my y coordinate going to be? -8. Okay. If my y coordinate is 2, what's my y coordinate going to be? So if my x coordinate is 2, what's my y coordinate going to be? 4, right? Okay. Could you complete that table of numbers for me? Okay. Okay, so you should have a table of numbers that looks something like this. Now what I can think of this as is as a coordinate. So this point here, for example, would be -4, -8. And this point here would be -3, -6, and so on. Okay? And in fact, if I was going to plot all these points, that's what I've done on the screen there. That's what I've done on the screen there. So I've gone through and I've plotted all these points together. Now, are you happy that I've just chosen to do all of the integers between -4 and 4? Okay? I could have stuck in -3.5, or I could have stuck in -1.8. It doesn't matter the degree of accuracy. So if I was going to plot the set of points, I would use the full set of the x's, the real numbers, okay? All of the numbers between -infinity and infinity. And if I was going to do that and join them together, I would hopefully get a line that looks something like this, okay? So you're happy if I was just going to connect all of those points together, that's the line which I would get. So that line there is y equals 2x. Now I wonder if you could tell me, what is the gradient of this line? So how steep is this line? So remember, the definition of gradient is, if I move across by 1 in this direction, okay, how many do I move up or down by? How many? 2. Yeah? Because if I move from -4 to -3, that's moving 1 across in the positive x direction. I'm going to move from -8 to -6, which is 2 up. Does that make sense? And I can keep going. So every time I move across by 1, I move 2 up, across by 1, 2 up, and so on. Okay? Now, can you see that from the graph? Can you see that from the graph? So if I move 1 across in that direction, can you see that I move 2 squares up? Okay? And actually, it doesn't matter where I start from. I could start from down here at C3, for example. If I move 1 step across, so I move from -2 to -1, I'm always going to move 2 up. Okay? So we'll say this line here has a constant gradient. Now, can you see that from here? Can you see where that 2 comes in here? So the number in front of the x, this number here, corresponds to the gradient. Because if you think about it, it tells me take my x-coordinate and times it by 2. And that's how I get my corresponding y-coordinate. Okay, so if I increase my x by 1, then I'm also going to increase my y by 2, because it's going to be 2 times my x increase. Does that make sense? So actually the number in front of my x in my equation corresponds to my gradient. All good? Good, excellent. So my next question is, well, what happens if I started to plot a different line? What happens if I plot not y equals 2x, but y equals 2x plus 1? So I do something else. I don't just times it by 2, I also add 1. Can anybody think what's going to happen? So, okay, so I'm still going to have a similar kind of thing what's going on here, except I'm going to add 1 as well. So now, if I draw out exactly the same set of points, so x going from -4 to 4, okay, same set of points, but this time my y-coordinate is going to change slightly because it's just going to be moved 1 up, yeah? So it's going to be not -8, it's going to be -7, not -6, it's going to be negative, okay, and so on. Sorry, -3, -1, 1, 3, where are we? 5, 7, 9, okay? So all of these y-coordinates have just been moved 1 up. Does that make sense? So on the graph then, you notice this graph at the moment, y equals 2x, passes through the origin, okay? If I add 1, all I'm doing is keeping the same gradient, but I'm just shifting it up by 1, okay? So I get this graph here, okay? Same gradient, but it's just been shifted up by 1, because all of the y-coordinates have just been moved up by 1, okay? So y equals 2x plus 1. My gradient is still here. My gradient is still here at 2. But the difference is now, the gradient is the same, but the line is just higher. Okay, it's been shifted up by 1. So in other words, what is my y-intercept? Where does it cross the y-axis? It's at 1, right? So this number here, the 1, tells me it's been moved up by 1. So that now then is my y-intercept. Okay? Good. So what do you think then my y-intercept is going to be with y equals 2x minus 1? Yeah, instead of going up by 1, it's going down by 1. Okay? But it's the same gradient. It's the same gradient. It's still exactly parallel to each other. Okay, so my intercept is y negative 1. Okay? So in general then, what we can say is that if we have a line that looks like this, so for example 3x plus 4, okay, my gradient is always going to be the number in front of the x. Okay, that's my gradient. That says if I move across by 1 in the positive x direction, I move up by, in this case, 3. Yeah? Where's my y-intercept? It's this number here, right? Okay? So that tells me how high or low that line is. So that's my y-intercept. So what we can do is generalize this, and we can say, okay, if I have y equals some number, let's call it m, times by x, plus another number, let's call it c, my m, this number here, corresponds to my gradient. Okay? And my c, whatever number goes on the end there, is just my y-intercept. Does that make sense? Does that make sense to everyone?